Hey guys, so this is 2.4 day 1. We are on slopes of tangent lines. Okay, so you've done this before. We did this at the very end of Enhanced Math 3, so this is not new information for you, but we are going in a little bit deeper than we did when we introduced this to you guys for the limits unit at the end of second semester Math 3. So it says the slope of the tangent line to the graph of a function at the point xy is the line that best approximates the slope of the graph at that point. Below are some examples of tangent lines. So, for instance, we have a tangent line against this part of the curve of the graph, against this part of the curve, of the graph, against this part of the curve of the graph, against this part of the curve of the graph, against this part of the curve of the graph. So we can approximate the slope of that particular point on the graph. We have to find a tangent line to that graph, find its slope, and then that's our best approximate. Okay, so tangent lines come in handy. So you're going to be doing a lot of linear things embedded with a lot of this stuff. So it says a tangent line can intersect the graph in more than one place, but it will only intersect once in the neighborhood we are looking at. So notice it intersects over here, but that's okay. I see that it's tangent over here. So here is our point of tangency. Point of tangency. Right there. Okay. So we're definitely going to be looking at that line that's tangent to that part of the graph and figuring out its slope so we can approximate a best slope for that curve of the graph. Okay, so number 1, it says estimate the slope of the tangent lines to the graphs at the indicated point. Okay, so in this first one, let me zoom in a little bit. We can see that we're tangent at this point, one half, and we need to try to estimate the slope. So the best next point would probably be about right here, and it looks like it's the same level as this positive 1 if I were to just about. So if I figure out the slope, remember some things about slope. Slope is the same as the rise over the run. The m in y equals mx plus b. But when we have a graph, we could totally just count the rise over the run. So to go from here, which is at a y value of 1/2, we're going up to 1. That means I'm going up 1/2. Going up is a positive move. And then I go over to this point. I'm going from an x value of 1 to an x value of 1.5. So I'm going over to the right by 1/2. Going to the right is also a positive move. So my rise is 1/2. My run is 1/2. 1/2 divided by 1/2 is 1. So the slope of that tangent line at that point is 1. It's not so bad, right? Now look at these. These look kind of funky. We have a tangent line going through the point -1, 2 at this curve of the graph. And we have a tangent line going through the point 1, 2 at this part of the graph. Okay, what kind of lines are those? If you said horizontal, you're right. These are horizontal lines. Sorry, I'm left-handed, so I gotta turn this a little bit. We've got horizontal lines right there. So remember what slope is. Slope is the rise over the run. But if we have a horizontal line, we're not going up at all. So we're going up 0. And we're going over, well, it just goes over and over and over and over and over and over and over. So that means we're going to infinity. But 0 divided by anything is 0. 0 is the only number that can wipe out infinity because 0 divided by anything is 0. So it doesn't matter what it is in the denominator. So the slope of that tangent line is 0 plus slopes of any horizontal line are 0. Stuff you guys learned way back in the day, like, I don't know, middle school, I want to say. Like, it's probably around the first times you've seen it. You might even see it in elementary school, because I know that my daughter was learning graphing in elementary school in the 6th grade, 5th and 6th grade. I don't know if she learned slope, though. Anyways. All right, letter C. We have a tangent line to that curve. So I want to highlight it. Man, it's hot, guys. We're trying not to use the AC that much, and it's like 80 degrees in the house, and I'm dying. I'm dying. Not really, but I feel like it. All right, so we have this point. The next exact point that I see on this line looks like it is right here at the point 2, 1. So I'm going down 2 over 1. Going down is a negative move. Going over to the right 1 is a positive move. So remember, slope equals rise over run. And in this case, the rise is -2. Over the run is 1. -2 divided by 1 is -2. Moving my left hand out of the way. All right. Let me fix the papers here. Okay, so it says the slope of the graph tangent to the line at any given point can be found by evaluating the derivative of that point. So we didn't specifically call it the derivative when we were going over this at the end of last semester during that limits unit. I don't think we officially used that word, but it is finding the derivative. At least in my class, I didn't officially use that word. I just said find the slope of the tangent line or find the formula for the slope of the tangent line. I never really said derivative. I didn't anyway. I don't know if Mrs. Ardito did it the same way, but we taught it the same. Anyways, so that formula in there should look highly familiar because you used it a lot during that limits unit. So this is the definition of a derivative. So you guys know f prime of x, that notation right here. That's what's new for you. So anytime you see, f prime of x or g prime of x, that means that we are giving the derivative. Okay, so that's the notation for derivative. And it's the limit as h approaches 0 of f of x plus h minus f of x all over h. So that should look highly, highly, highly familiar to you guys because we used that quite a bit. You guys had a lot of practice problems working with those at the end of last semester. Yeah, you were doing it at home, but for the most part, aside from some of the cheating, there was a lot of really good scores on that test where there was legitimate work shown. So I'm going to trust that that was legit, and you guys did that pretty darn good. So this isn't bad, I promise, okay? So example 2, we're going to find the slope of the graph at the given point, okay? So here's the first step. Let me turn it a little bit because I'm a lefty and I have to do this. So I'm going to use this definition. So I'm going to have the limit as h approaches 0. I'm so used to writing an x. Now I have to plug in an x plus h wherever I see an x. So x plus h quantity squared, that's all I got to do, minus the original function, so minus x squared all over h. Okay. My next step is to simplify that out. So I'm going to need to simplify. Okay. So when I multiply out, let me get this right, hold on. The limit as h approaches 0. As I multiply that out, that's really x plus h times x plus h. And what you'll get is x squared plus 2xh plus h squared when you multiply that out. You might even remember that because I'm sure you had it memorized, because we used it so much end of last semester, okay? And we're still simplifying because we can combine like terms and stuff's gonna cancel. Like I have a positive x squared and a negative x squared, they gone. And all I have left is 2xh plus h squared all over h. So each has a factor of h that I can cancel out. Remember, when you cancel out something, it's all or nothing. They either all have it or you can't cancel a thing. So they all have it, so we can cancel out the h. This one just goes down by 1, so that's an h to the first up there. Okay, so I have the limit as h approaches 0 of, let's see, I have a 2x plus an h to the first. I don't have a denominator anymore, okay? So once I get there, now I could plug in the 0 for h, and I'm going to get 2x plus 0, okay? And now I can find the slope of the graph at the given point. Remember they gave us this point, negative 2, 4. Remember from end of last semester, we only need the x value. We just have to plug in the x value from that given point. So that would be 2 times a negative 2, which equals negative 4. So the slope of the graph at that given point is negative 4. Okay, let's go ahead and graph it. So f of x equals x squared, that is the parent function. So that means it's of a quadratic. So we have a vertex at 0, 0. I'd have a point at 1, 1 and negative 1, 1, and a point at 2, 1, 2, 3, 4, and negative 2, 1, 2, 3, 4. And I have my parabola. Sorry if I'm a little goofy today. It's been a good day, actually. So, yeah, it's nice when we have a good day. I went for a run this morning. It's Saturday. It's Saturday night right now, actually. I went for a run. I did 7.5 miles. I was so proud of myself, and I pushed myself through all the hills, and I just felt amazing. And the weather was nice this morning up in Wrightwood, and I just loved it. And it just helped re-energize me, you know, and I was able to clear my head and able to just let go of some frustrations from this past week, and that was beautiful. Anyways, so the point that it was that in question was negative 2, negative 4. So this point. So when we're finding its slope, we're finding the slope of the tangent line at that point. And I totally suck at drawing that. But if we look at the slope down 1, 2, 3, 4 over 1 approximately, there's our slope of negative 4. Okay, so there's our graph that shows that. So we could have even graphed that and tried to find the slope of the line tangent to that curve right there. The only thing about doing it by hand like that is that we are trusting our drawing skills. And I don't know about you, but I would not trust my drawing skills. All right, we're going to skip this one just because we don't need that example. We'll be good. Because this is all review for you guys. All right, example 3. Okay, so what are we doing now? It says that we need to find the formula for the slope of the graph at any given point. So now we're not plugging in an x value point. We're just finding the formula. So like in the last example, you know how it stopped at 2x? That would be the formula, okay? So we're basically finding a formula for the derivative, all right? So I want to go over some terminology here that you're going to hear a lot. So you're going to hear that you need to find the slope of the tangent line, which you've already seen. You're also going to hear that you need to find the formula for the slope. You're also going to hear find the derivative. Well, guess what? All of those things mean exactly the same thing. Okay? So when you're asked for these things, they just use different terminology just to make sure that you know what you're doing. So you have to know this terminology just means that you're looking for the same thing. Okay? Essentially, you're finding the derivative. Okay? So let's go ahead and remember we have to use our little formula. So that's, you know, the limit as h approaches 0 of f of x plus h minus f of x all over h. So just remember, that's what we're looking for, okay? All right, so next part, let's do it. So we have the limit as h approaches 0 of, I need to plug in an x plus h for all the x's. So I'll have 3 times x plus h quantity squared minus 2 times x plus h, and then minus the f of x function, which was this. But if I'm subtracting 3x squared, it'll be a minus 3x squared. If I'm subtracting a negative 2x, negative turns positive, so plus 2x. You have to distribute that negative all over h. Okay? So the next step is, just like in the last example, we gotta simplify. Sorry for my left-handedness. I cannot help it. The limit as h approaches 0 of, okay, when I multiply x plus h quantity squared, it's x squared plus 2xh plus h squared. But now I got to multiply each of those terms by 3. So 3x squared. 3 times 2xh is 6xh. 3 times h squared is 3h squared. Oh my gosh, I can't even talk anymore. What's wrong with me? Okay, I'm okay. Distribute that -2, we'll get -2h minus 2h. And I'm going to squeeze in there the -3x squared plus 2x. Yeah, as I'm squeezing stuff in, notice how it gets smaller and smaller. Oops, all over h. Can't forget that. Oh my gosh. Okay, let's get a little cancel happy. We have a 3x squared and a -3x squared. They gone. We have a -2x and a positive 2x. They gone. So all I have left is 6xh plus 3h squared minus 2h all over h. So all 4 terms have an h, so that means that I could cancel out an h from each of them. Cancel, cancel, drop down 1, cancel. So I have the limit as h approaches 0 of, I have a 6x, so that sounded weird, plus 3h minus 2. The only thing about counting stuff out is sometimes I forget the constant. I don't know if you guys do that too. So be careful about that. Okay, now we could plug in the 0 for h. And we know that 0 times anything is 0, so that 3 gets wiped out. So my formula then is f prime of x, because that represents the derivative, because that's what we're finding. The formula for derivative is 6x. That's going to go to 0, and then minus 2. There's our formula. Isn't that so easy, guys? It's just algebra. We're just using algebra. All right, let's try example 4. This is our last example. We're going to find, guess what, the derivative. It's straight up asking for the derivative this time. So straight and to the point, how I like it. Okay, g of x equals the square root of x. All right, let's set this up. So we're going to have the limit as h approaches 0 of the square root of x plus h minus the square root of x all over h. Now, when we have a radical like that, you guys remember what you got to do? We've got to reverse rationalize, okay? So that means I have to multiply top and bottom by the conjugate of that radical numerator, because it's so totally radical, dude. Okay, so square root of x plus h. And the conjugate of this would be the same thing, but with a plus. Always an opposite sign. I like parentheses because they make it look normal. And I like to be normal sometimes, but normal is kind of overrated. All right, so we're going to have the limit as h approaches 0. Square root of x plus h times square root of x plus h. The x plus h gets to come out of the radical. Square root of x plus h times positive square root of x. I'm going to keep in my head because I see a negative square root of x times square root of x plus h, and they cancel each other out. And then negative square root of x times square root of x is a negative x, because x gets to come out of the radical. See how easy that was? Remember to keep the junk in the trunk. So h times square root of x plus h plus square root of x. Remember, don't ever, ever, ever multiply out the denominator. Just don't do it. I know that you might want to. Just don't do it. Refrain. I'm sorry, I'm really weird today, guys. Okay, so let's cancel those out because x minus x is 0. I'm such a nerd. I'm so sorry. Okay, so the limit as h approaches 0 of h over h. Oh, I should have canceled that out in the last step. Oh, well. Times square root of x plus h plus square root of x. Like I was saying to myself a moment ago, those h's cancel. Remember, when something cancels like that, it turns into a 1. H divided by h is 1. Okay. And so now I have the limit as h approaches 0. Oops, I make sure you guys can see. Of 1 over the square root of x plus h plus the square root of x. And now we could plug in the 0. So x plus 0 is just x, okay? So I really just have, I'm having trouble switching pens. Don't roll away. All right, 1 over the square root of x plus the square root of x. All right, I think I'm ready for my formula. So this function's name was g of x, so the derivative would be g prime of x equals 1 over, there's 2 square roots of x there, so 2 square root of x. And that is the formula, the derivative. It's actually kind of fun to say the word derivative, derivative, derivative. You know you just tried it. Okay, let's try letter B. Again, I'm so sorry, I'm weird. Okay. F of x equals 1 over x plus 3. So we have the limit as h approaches 0 of, we got to plug in the x plus h into the x's there. So 1 over x plus h plus 3 minus the original 1 over x plus 3 all over h. I know these are your absolute favorite. Whenever you see fractions, you're like, yay, I get to do fractions. I get to get a common denominator, because that's what we got to do. So we have this factor in this denominator and this different factor in the other denominator. So to make them have the same denominator, we got to multiply them together. So I got to multiply top and bottom by x plus 3, because this one is missing x plus 3. And I got to multiply this one top and bottom by x plus h plus 3, because that's what this one is missing. Okay. So I'm going to have the limit as h approaches 0 of my common denominator in the numerator is going to have an x plus 3 and an x plus h plus 3. The numerator is going to have an x plus 3 minus the quantity x plus h plus 3. So minus x, and then minus h, and then minus 3, because you got to distribute that negative. And remember, this is all over h. So it still looks kind of messy, but it's okay. All right, x minus x, they gone. 3 minus 3, they gone. All right, so we've got the limit as h approaches 0 of, I have a negative h all over x plus 3 times x plus h plus 3, and it's divided by h. I'm going to put that h over 1. Dividing fractions is easy as pie. You flip the second, which is h over 1, and multiply. So flip h over 1, you get 1 over h, and guess what? We get to cancel out an h. Boom, shakalaka. Okay, so I'm going to have the limit as h approaches 0, tired of writing that yet, of 1 over x plus 3 times x plus h plus 3. Okay, now we could plug in that 0. So I have, switching colors, 1 over x plus 3 times, when the h is 0, I just have x plus 0 plus 3, which is just x plus 3. All right, I think I'm ready for the formula. The derivative, this function's name was f, so the derivative will be f prime of x equals 1 over x plus 3, and since there's 2 factors of them, it's quantity squared. All right, so your your homework is going to be on page 808, numbers 1 through 18. This is not the same page 808 as in your book. I have uploaded it. It looks like this. So you're doing 1 through 18. So you're starting at this one, not the vocabulary check one. This one, and you're going all the way to 18. So notice that this part is completely la 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 la. Don't do it. Okay. So 1 through 18. Okay? All right. Have a good one, you guys. I'll see you in my next video.